These slides are about Ampere's law. The line integral of B dot ds around any closed path equals mu naught I, where I is the total continuous current passing through any surface bounded by the closed path. So integral of B dot ds is equal to mu naught I. When the wire carries a strong steady current, the needles all deflects in a direction tangent to the circle. These observations demonstrate that the direction of the magnetic field produced by the current in the wire is consistent with the right-hand rule described. When the current is reversed, the needle in the figure also reversed. Now let us evaluate the product of vector B dot ds for a small length element ds on the circular path defined by the compass needles, and sum the products for all elements over the closed circular path. Along this path, the vector ds and b are parallel at each point. So vector B dot ds is equal to bds. Furthermore, the magnitude of vector B is constant on this circle. Therefore, the sum of the product B ds over the closed path, which is equivalent to the line integral of vector B dot ds, is integral vector B dot ds is equal to B integral ds, which is equal to mu naught I divided by 2 pi r into 2 pi r, which is equal to mu naught I. A solenoid is a long wire wound in the form of a helix. With this configuration, a reasonably uniform magnetic field can be produced in the space surrounded by the turns of wire. Magnetic field lines for a tightly wound solenoid of finite length carrying a steady current. The field in the interior space is nearly uniform and strong. Note that the field lines resemble those of a bar magnet, meaning that the solenoid effectively has north and south poles. Cross-sectional view of an ideal solenoid, where the interior magnetic field is uniform and the exterior field is zero. Ampere's law applied to the red dashed path can be used to calculate the magnitude of the interior field. So integral of vector B dot ds is equal to integral of path 1 B dot ds equal to B integral of path 1 ds, and it is equal to BL. And integral of B dot ds, which is equal to BL, and which is equal to mu naught Ni. And from here B is equal to mu naught N divided by L into I, and it is equal to mu naught Ni.